Dear student, as I promised that I'm going to continue the physics chapter. In previous video I have talked about 18.1 and 18.2 of the electromagnetism, which is a very big topic, so I will split it into two topics for each day. So today I'm going to talk about the topic 18.3 and 18.4, which talk about magnetic field, what are the magnetic domains, how it is magnetization, demagnetization happen. So if you want to see my previous video from 18.1 and 18.2, please go through the previous video, it is available over there. Now let's talk about then this magnetization and demagnetization. Okay, so it has been suggested that actually if you look at magnet, okay, whenever you split it will always form the north pole south pole, north pole south pole. It means the magnet has very peculiar the polarity they have. Now why they have a different polarity? It means there is something inside happening in the magnet. So physicists still believe that due to the motion of the electron, the electron constantly moving in the orbit, due to this motion there are some magnetic field are generated at the atomic level. Okay, now this is called atomic magnet. So we have to look this magnet in very zoom in. So now when the multiple magnetic atomic domain which have the same direction, okay, that is called magnetic domain. So atomic domain, atomic magnet and magnetic domain, what is the difference? Atomic magnet is basically, it is very small level where the electrons are rotating, and because of that motion they are magnetic field are generating. So it's behaving like small magnet because they are generating a polarity. Now if the atomic magnet which have same direction, these are called magnetic domains. So what is magnetic domains? It consists of group of atomic magnet pointing in the same direction. Okay, now let's talk about, okay, when you magnetize the steel bar, okay, what happened basically? So just now what we have talked about magnetic domains, they are the magnetic domains which have same directions. In the one element it can be different direction they might have. So now what we have to do, we have to organize them in the same direction so that they will get a polarity. That is called magnetization. So during magnetization the magnetic domains become aligned, they point in the same direction. So let's talk about in this condition. Okay, so this is unmagnetized bar, means this was not showing any magnetic property. But when we magnetize this by whatever method which we're going to discuss just in a while, they start aligning themselves. Okay, so here is randomly, then though there's no magnetization. Okay, there's no magnetization between this, they cancel out each effect, because one is going up, one is going down, and they're all cancelled, there's no effect. When magnetization happen, it is induced, they align in certain orientation, okay, like this. And in this condition you will say they have got a polarity. Okay, so in this what we say, that each arrow is aligned directly behind the arrow. Okay, so align it is like that. Therefore the north pole are cancelled out by adjacent south pole. Now what happened? The atomic magnet at the both ends are free. Okay, if you think the both ends, and now it's free, and this produces the effect of north and south pole. So this part, if you think the last part, it is not cancelled out, and they will give you a polarity. Okay, so the atomic magnet at the end tends to fan out due to the repulsion between the like poles, obviously, which you can see here clearly, that the south pole which have similar kind of polarity, they started going away from each other. Okay, by this, even for north pole also. So in this way magnet is getting the clear polarity of north pole and south pole. Now how we do that? Okay, how we magnetize it? So let's talk about, there are basically two methods where which you can magnetize the magnet. First is called stroking, second is method is called electrical method, which is the direct method. Okay, so what is the stroking? Stroking is basically a process in which a steel bar which was unmagnetized bar, it was stroked several times by the permanent magnet in same direction. So in this way what happened, this is induced, okay, the magnetic domains are induced to align themselves in the same direction. So it should be the stroking, when we stroke you have to always make sure that the stroking magnet should be lifted sufficiently high above the steel bar between the successive strokes, so that it will be, induction will be the better. Now if it is north pole, okay, so the pole induced to this side will be the opposite part. So the pole produced at the end of the steel bar where the stroke finished is opposite to the stroking pole. This is what they are saying here. Now let's talk about in electrical method what is happening, okay, which is via direct current. Why we are using direct current? Because in direct current, so they are, you should understand, current is basically two way you can produce, okay. Current can be produced in two way. One is called DC, which is direct current. One is called AC, which is alternating current, okay. Now if you think direct current, basically there is no direction, they always flow in the same direction. However in alternating current they follow in different direction, okay, and they used to change like how the waves change. So DC is mainly it produced by the cells, and AC you will see it is produced by the AC generator, or you know, in our house supply alternating current, which is very powerful. So we should not use AC current when we are making a magnetization process, when we are in magnetization process. So here what we will do, we have to bring a DC supply, and there is a solenoid which is nothing but a coil of wire. You put the bar which you want to magnetize inside the solenoid, and now the current will flow. So when the large current will flow, strong magnetic field will be produced in the solenoid, okay, and this will induce the magnetic domain to organize in a particular direction, and they will give the polarity. So this is how the magnetic field, the magnetization can be done, okay. Now if magnetization is done, now you have a bar magnet just unlabeled. Now how you know which is what pole, which is north pole induced, which is south pole induced? Because in this condition you are not sure, and you know there's not like color coding. So to figure out what direction it is, if the clockwise current is following in clockwise direction, that end will be the south pole. Now if you look this direction, okay, you have to look from this side, okay, you have to keep your eye and you have to look from this side, that if you look this side, how the current is following. So if you look this current, it is following to the clockwise, okay. That's why at this side there will be south pole will generated. Now you put your eyes here and try to look from this side how the current is following. So if you look this eye, you will realize that okay, its current is going, if you look at this part, it will look like going in this direction, you know, it's going from that side to this side, it's in reverse, which is the anti-clockwise. So that end will be north pole. So this is the one way. Second way is, say, the right hand grip rule, where you put your right hand and grip your finger along the direction of where the curls of the solenoid is going on. Now the point of the thumb will tell you the north pole. So if you know one pole, you can figure out what is another pole, which will be the south pole. I hope this clarification is clear for magnetic field, and how to figure out the magnetization process, how to figure out the different poles you have. Now let's talk about, okay, if I have a magnet now, you know, you can demagnetize them. So how you can do that? So the process is that whatever you have just now seen magnetic domain, that they are aligned in a nice orientation, you just shake it. Shake it means you just try to disorganize them. So how you can do? The first process is called heating. So if you heat it multiple times, it is going to break that chain of the polarity of all the domains, okay. So it have to heat strongly to magnet and let them cool in east-west direction. Always remember, whenever you're doing this process, you don't have to organize them in the north-south direction, where they will be again organized by itself. So you have to write in this orientation. So this will cause the magnet to lose its magnetism, okay. Now the atom of the magnet vibrate vigorously when heated. this causing the magnetic domain to lose the alignment. So you know now what is happening in the heating. So when we heat, it's vibrate a lot. So when atomic magnet vibrate, obviously then magnetic domain will vibrate and they will disalign. Now what is the second method? Is called hammering. Okay, so hammering is a magnetic placed in the east-west direction. Again you have to placed in the east-west direction, and then you try to hammer. That will again alter the magnetic domains. Okay, and then it will lose the magnetism. Third point is very effective, called the electrical method, where you provide the alternating current. Just now we have discussed in previous in magnetization AC current, right? Direct current, sorry, DC current. Now here we are talking about alternating current. Why? Because you want this magnet to change the orientations. Okay, so one time current will go this direction, next time current will go in this direction. So in this way what happens, the domains are completely disorganized. So let's see the step by step process. So first, place a magnet inside a solenoid in east-west direction. So all the demagnetization process we have to do east-west direction very clearly. Okay, so it will make sure that magnet completely lose their orientation, which naturally they try to organize in the north-south direction. Now you provide the alternating current. Why? Because an alternating current which varies direction many times per second, and it will help them to disorganize the atomic domain. Now what you have to do, withdraw the magnet with alternating current still showing in the solenoid until it is some distance away. So you know you have to remove the magnet slowly until the current is still following it. So there will be still some effect till the time you have to draw the magnet for some time. So pulling of this magnet should be very slow, so that it should be the stable, the domain which is magnetic domain which is disturbed, it should be stable. So you have to remove this magnet slowly. Again remember, this would be in east-west direction, and till you are removing, the current might be go on this AC current, which make sure again that still it is demagnetization process, and now it will be complete. It will lose the polarity completely. So now let's see some of the question from here. Okay, let's recapitulate first of all what we have learned: how to magnetize it by stroking, by putting the DC current. Okay, how to demagnetize: when you heat the magnet, when you hammer it, and when you put in the AC current, which is alternating current. Now let's talk about some of the question from this part. State the difference between the unmagnetized steel bar and magnetized steel bar in terms of their magnetic domain. So it's very clearly they are saying unmagnetized steel bar. Just now we have discussed that what happens in unmagnetized steel bar, the magnetic domains are not oriented in particular direction. However, when it is magnetized, they are aligned in a particular one direction, and finally they generate a polarity. Now the second method, just now we have discussed what are the three methods of the demagnetization. You can write this three method. Now question number 3, a steel bar can be magnetized by stroking it with two magnets as shown in this figure 18.3. Okay, so you are stroking it. Mark the resulting pole of the steel bar on the figure 18.3. So if this is the steel bar which is we are stroking it, okay, so as you can see here, if this is the south, it means this will be the north side, correct? So if this is the north, it will be the and so also see the direction of this magnetic field is going in these directions, will be south, north, and this will be your again north, south. So this will be a polarity that it will be generating the north pole to this side. Okay, so this is one of the efficient way where the two magnet which have different poles are stroking each other. So if this is your north, this will be the south, so they will cancel each other, and finally you have the polarity south this side and north this side. Okay, Now question number 4, a magnet is placed in a solenoid carrying alternating current and withdrawn slowly in its direction until it is far away from the solenoid. Explain what will happen to the magnet in terms of its magnetic domain. So just now we have discussed the process of demagnetization. So now when it is far away from the solenoid, it is already demagnetized, so it will lose the alignment and magnetic domain will be now disaligned. Okay, it will not in particular direction. So I hope you like this video. If you like, you can write the comment. If you want to say something or discuss something, please share with your friends, so they will also get help from it. Thank you.